All right, for problem number 27, we're trying to find the area under the curve, 3 minus x, from negative 2 to 2. So remember, the formula we're going to use here is we're going to find the limit as n approaches infinity of the sum from k equals 1 to n of delta x times f of x sub k. So now what we're going to do is we need to figure out a couple things to set this up. We need to know what delta x is. Remember, that's b minus a over n. So delta x is going to be 2 minus negative 2 over n. So we get 4 over n for our delta x. X sub k, that one, remember, is going to be a plus k times delta x. So our a value is negative 2 plus k times delta x, that's 4 over n. So we have our two things that we need in order to plug them in to our limit. So delta x is going to be 4 over n, and x sub k is negative 2 plus k times 4 over n. All right, so let's go ahead and set this up. We're finding the limit as n approaches infinity of the sum from k equals 1 to n of delta x, so in this case it's 4 over n, times f of x sub k. So x sub k is this whole thing, negative 2 plus k times 4 over n, but that whole thing is going into our function, so it has to take the place of x. So we have 3 minus that whole thing. So we need to go ahead and do a little simplifying here. We can distribute that minus. So limit as n approaches infinity of the sum of k equals 1 to n of 4 over n times, so we get 3 minus negative 2, so we're going to have 5, and then distribute that minus. We have minus 4 over n k. Now we can distribute that 4 over n. So we have limit as n approaches infinity of the sum from k equals 1 to n of, we distribute that, we get 20 over n minus 16 over n squared times k. Now we can split this up. I'm not going to actually split up the whole thing. We've done it on the other ones. But if we take the sum of 20 over n, that's just a constant. We still have that limit as n approaches infinity out in front, but this is just a constant. So if we take the sum of a constant, it's that constant times n. So we have 20 over n times n. So that is the sum of this one from the formulas we talked about last week. And now we have minus the constant, we can stay out in front, 16 over n squared, times the sum of k. Remember, that was the formula, n times n plus 1 all over 2. All right, so the constant stays out in front, times the sum of k is using this formula. All right, a little bit of simplifying here. The n's cancel out. Over here, this n cancels out with one of those, 16 over 2, so this is 8 over 1. So now we have the limit as n approaches infinity of 20 minus, we distribute that 8, we get 8n plus 8 all over n. We can split that one up. So limit as n approaches infinity of 20 minus 8n over n, and I want to distribute that minus, so it's going to be minus 8 over n. So here, n's cancel out. We have the limit as n approaches infinity of 20 minus 8, so that's 12 minus 8 over n. And remember, the limit of a constant is just a constant. Limit as n approaches infinity of a number over n to any power, any positive power, is going to give us 0. So our limit for this one is 12. The total area under that curve is 12.